Hello students, welcome to ABHIRAM IAS Academy. So today, what if I told you that the clean fuel of the future, that is natural hydrogen, is present beneath your feet but yet to be discovered. Do you know this? Okay, confused? Let me make you clear here now. So basically, the clean fuel of future, that is clean fuel of future, that is here natural hydrogen or white hydrogen, natural hydrogen or white hydrogen is present in the rocks. So recently there was a discovery that this natural hydrogen is found in the regions of Andaman and Nicobar Islands. Andaman and Nicobar Islands. Now, you can ask me, so what? Right? So, you can ask me, so what? So, basically, now, this natural hydrogen is our clean energy or else clean fuel where we are using for some like cooking gases, electricity generation. Now, what happens if the natural hydrogen is coming from the earth? Then it is free of cost. So low cost and high energy, right? So that we can achieve one of our Panchamrit goal, that is net zero emission by the year 2070, right? And this is leading to the decrease of the global warming, and indirectly we are supporting for the climate change. Right? We are supporting for the climate change. So basically, natural hydrogen recently we were found in the Andaman and Nicobar Islands. This natural hydrogen is also called as white hydrogen, and it is found in the Earth's crust. Clear? Unlike the industrially produced hydrogens. For example, your green hydrogen, pink hydrogen, yellow hydrogen, etc. Okay, confused with these colors? Let's see what the colors are representing here. First, grey hydrogen, what it is representing? So basically this grey hydrogen is formed from the natural gas. Okay, for example is here methane, and it is produced via the stream methane reforming process. Next, coming to your blue hydrogen. See here blue, anything refers to the water, right? So made from the oceans by capturing carbon capture and storage method. Next is the green hydrogen, that is which is produced from the water electrolysis, that is the electrolysis of water where you break down the water molecule and it is forming 2H2 plus O2, right? So you are getting here hydrogen. So green hydrogen, that means which is produced from the water electrolysis using the renewable energy. Turquoise hydrogen, it is produced from methane pyrolysis, which is splitting methane into hydrogen and carbon. Clear? That is CH4 is converting into hydrogen molecules plus carbon molecule. Next is pink hydrogen. So it is from the electrolysis using the nuclear power. And last is the black hydrogen or brown hydrogen, that is formed due to the coal gasification method. So coal gasification, and here black is indicating bituminous coal and brown is representing the lignite coal. Clear? So these are the different colors of the hydrogen and the respective sources of it. Now further, let's see how this natural hydrogen is formed. So basically there are three methods where we can form this natural hydrogen or how the natural hydrogen is formed. So first is serpentinization. Don't get confused with the name, it is easy. Serpentinization, which means the reaction between water and iron rich rocks. Clear? Rocks, where do we form? In the earth crust. So it is a combination of water plus hydrogen rich rocks, that is here serpentinization, and from that our hydrogen is formed. That is the natural hydrogen. Now next is radiolysis, which means breakdowning of something with respect to the radioactive rocks. Okay, so breakdown of water molecules by the radioactive rocks. Clear? That is the radiolysis. And first is serpentinization, which means breakdown of water and also iron-rich rocks. Further is radiolysis, that is breakdown of water molecules by radioactive rocks. And next is decomposition of organic matter, where it is giving the ultimately our hydrogen molecules. And these three are the formations of clean hydrogen or your white hydrogen or natural hydrogen. Clear? Natural hydrogen. See, that means these are all present in the atmosphere itself. Clear? Under our feet. So that is why I told the natural hydrogen is formed, it is available beneath our feet, but only the thing is extraction process is remaining, and discovery along with Andaman and Nicobar Islands, we are like scientists are searching for the hydrogen in other places too. Now, what are the benefits of this natural hydrogen? First is our energy security, where it is reducing the fossil fuel dependency, and also it is enhancing the strategic autonomy of India. Clear? And next is climate goals. As we saw, our Panchamrit goal is net zero emissions by the year 2070. Now, with this natural hydrogen, we are able to success the net zero emissions by the year 2070. Clear? So climate goals and also economic impacts. So we can have low economy dependency. Low economic dependency as it is founding naturally. Clear? So lower white hydrogen production, the cost will be decreased, and it opens a new industry for this kind of natural hydrogen production. Clear? Now, let's see the estimations. So basically, India, now current demand is 6 million tons per year. But after 2070, the projected demand is 50 million tons per year. And further, estimated natural resources is around 3,475 million tons per year. Can you see? In 2020, the current demand is like 6 million per tons, but it has rapidly increased. Like projected for 2070 is 50 million tons. But see, 8 times of increase you can see here, where by the year, if the natural estimate, if we are founding the natural hydrogen, then the estimated is we can use 3,475 million tons per year. Now further, let's see the geological study parameters where we can found this natural hydrogen. So basically we have to test the rock quality and also the thickness of the rock and also the accessibility and hydrocarbon potential. And further we have to see the effective sealing and traps and also the size and variability of accumulations and also migration losses and also exploration feasibilities. These are all the geological study parameters for the rocks of the hydrogen, where we are able to find the hydrogen in the Earth's crust. Now, let's see what are the challenges in the exploration of this hydrogen gas. So basically, first is lack of mature exploration methods, as we didn't even know that natural hydrogen is present in the rocks. So now India has to find the extraction processes. That is, so we are lacking in the mature extraction processes, and also it is difficulty in detecting first. We already detected in the Andaman and Nicobar Islands. Now scientists are they are doing research to find in the other states too. So difficult in detecting and quantifying the subsurface hydrogen layers, and also hydrogen has small molecular size and high diffusibility, which is leading to the potential leakages. So the founded natural hydrogen we have to be stored, but we are lacking that infrastructure. And need for hydrogen specific drilling and also extraction infrastructure, and further hydrogen resistant coatings and alloys, that is the containers we need to find, and further modified rubber and cement to prevent the degradation of the hydrogen. So these are the challenges where we are lacking, where India is lacking, and it has to be improved. Mainly the infrastructure has to be improved for the storage of this white hydrogen or natural hydrogen. Clear? Next. Next, let's see how India can kickstart this process then. We have given the challenges and it is our prime duty to give the way forward also. So basically, we have to learn from solar PV, that is photovoltaic machine, where it can replicate the SRRA project. So what is SRRA? It is nothing but solar radiation resource assessment, and also India should go for the public-private partnership. So India should go for public-private partnership to identify this natural hydrogen rich sites. Clear? First is it should replicate the SRRA project, that is the solar radiation resource assessment project, and also we have to take the help of public-private partnership to identify the hydrogen-rich sites apart from the Andaman and Nicobar Islands, and further adopt the global innovations. Like for example, we have to take consideration from US Advanced Research Projects Agency Projects Energy Model, where it is producing the hydrogen by injecting water into the rock and combine this hydrogen production with the carbon sequestration. Clear? And next is the involving Indian oil and gas industry, where we have to drill into the rocks. So use existing rock samples and wells for drilling so that we can find the natural hydrogen. Clear? And also explore more wells with the financial support, and also retrofit some of the existing gas pipelines for the hydrogen transportation. So clear? We have given the challenges and these are the way forwards. Now, what is the conclusion we have to give? The conclusion is that, so India is going for the energy independence, and also with that in energy independence we are getting the low cost fuel, and also we are able to achieve our climate action. What is that? Net zero emissions by the year 2070, where this is one of our Panchamrit goal. Clear? So if India is able to find the natural hydrogen from the Earth's crust, we can decrease our energy independency. We can decrease our energy independence. Clear? That is why natural gas is now called as clean fuel of future. And this clean fuel of future is under our feet. The only thing what we are lacking is extraction. Yes, extraction and discovery. Extraction and discovery is the need of the hour. And how we can extract? By increasing our infrastructure. Clear? So this is all about the white hydrogen, natural hydrogen, or the fuel of the future. Thank you.